Today we're going to be reviewing trigonometric functions, and there's a lot happening in this lesson. So the first thing I want to review that I don't think a lot of students realize what radian measure is a radian measure is we have some circle with radius r. And 1 radian is if I take this length and I wrap it around the circle, that same r, that is my arc length. Okay, and that is 1 radian. And there's a key formula to remembering this, what the formula for this measure of this arc is, or I should say the length of that arc is S equals r times theta, where theta is in radians. So I need to find the length of the arc. So we're going to use S equals r theta. Radius is 5. And our central angle is 123. So our theta is 123, but I need to convert that to radians. And in calculus, we're going to round to 3 decimal places. So 10.734. So your answer needs to be correct to 3 decimal places. Okay, so what this slide is about, is if you have a point on a terminal side, what is the relationship between x, y, and r in our trig functions? You should remember this. I covered this in my Algebra 2 class. You covered this a bunch in pre-calculus. But just as a reminder, the sine is y over r, cosine is x over r, tangent's y over x, and then you have your reciprocal functions. And I always like to set these up in this chart. You just need to remember sine, cosine, tangent, and then your reciprocal functions. Another thing I also expect everyone to remember is R. That's not right. That's not good English. Are the graphs of our trigonometric functions. So you need to know how to graph all these. I'm not going to go through how to graph them, but what I do want to recognize is the even function versus odd function when we're looking at the graph. Remember, even means I'm symmetric across the across the y-axis, which means, remember, even f of x equals f of negative x. So an even function here would be cosine and the secant function. Now odd functions were symmetric across the origin, and f of negative x equals negative f of x. So our odd functions are the other ones. Sine of x and its reciprocal, cosecant of x, and tangent and its reciprocal, cotangent of x. Now, graphing functions, remember, you should remember all this. I kind of talked about this in other videos. Remember, this is our amplitude. So our amplitude is the absolute value of A. Remember to get the period. It's 2 pi over B. The phase shift, unless your B is factored out, it's going to be C over B. And then shifting up and down. In this example, we're graphing a sine function. There's a whole lot happening in here. Just remember that whenever you're graphing a sine function, you first have to factor out that B so that you know what your phase shift is. So then our amplitude is the opposite of this A value, so that's 2. Your period is 2 pi over B, which is 4, and then your phase shift is C over B, or if you factored it out, it's just this pi over 4, and then since it's a minus, you're going to the left. So how I graph these is I set up my amplitude along my y-axis. I graph my phase shift first. Okay, and then your period, which if I were to simplify that, is pi over 2 or 2 pi over 4. So I have 1 pi over 4, and then I have another pi over 4. So remember that this is how long it takes my graph to go through one rotation. So here I start at my amplitude. I start on the x-axis and on the x-axis for a sine graph. Halfway in between these points, I have another 0. Halfway in between, at negative pi over 8 and pi over 8, we're at our amplitude. Since the 2 is negative, you go down first and then up. So this is what your sine curve looks like. I like to graph 2 of my periods. So if I were to add another pi over 2 to this, so if 1/4 plus 1/2 is 3 pi over 4. Halfway in between I have a 0. Ending my amplitude, halfway in between I'm down and up. And so that's what our graph looks like. Now domain and range, again, I always forget this, re-recording for this new year. Domain, I can plug in anything that I want, so that's all real numbers. Your range, what is your highest, what's your lowest? You're ranging between what your amplitude is, -2 and 2. Okay, so our 6 basic trig functions graphed in the figure, so the figure that I showed you earlier, these are not one-to-one. So therefore we have to restrict the domain of the original to then be able to get an output for inverses. So what that means is, okay, when I'm looking at my cosine function, I've restricted the graph of the original function from 0 to pi, so quadrant 1 and quadrant 2, so that I can then take the inverse of that function, sine. Notice this restriction. Yes, that's quadrant 1 and quadrant 4, but keep in mind that this right here, negative pi over 2, this is in quadrant 4, you're dealing with the negative versions of your angles. And then inverse tangent's the same thing. Honestly, we don't see a lot of the inverse of the reciprocal function, so I wouldn't worry too much about those. But you need to know this. This is probably one of the most missed things that I find. Okay, our next example. So here we need to solve for x. So we do our inverse cosine of 0.4 is equal to x. We're going to be working with radians. So when I type this in my calculator, make sure you're in radian mode because we are rad. Okay, so I get this from my calculator. Now, but I need this in the quadrant in quadrant 4. So what this is this is the reference angle. So in quadrant 1, this angle here is 1.159. I need that same angle down in quadrant 4. So that's the reference angle, 1.159. So what I do is I take 2 pi, because I'm looking for this angle rotating from 0 to that terminal side, and I subtract the reference angle, and again that's calculator work, 5.124. That's if I have a restriction. On this next example, I don't have a restriction, so I do my inverse tangent of -3, and in my calculator I get -1.249. So that's my answer, plus all of my rotations. Tangents, period. Tangent repeats every pi. So that's why I add plus 2 pi k. Remember, k is standing for integers. Integers. Where those are rotations around my circle. Okay, but it's really multiples of pi since tangent repeats every pi. If you're working with sine or cosine, you'd have to have the two angles, and then you would have you'd have 2 pi in there. Okay, evaluate each one of the following, and these would be considered non-calculator questions. Okay, inverse sine of -1/2. So you have to know your unit circle and go to where inverse sine is -1/2. Well, sine is negative in quadrant 3 and quadrant 4. But remember, inverse sine only deals with quadrants 1 and 4. So I know I'm dealing with quadrant 4, so I need to know the angle where my sine equals -1/2. A lot of you guys are going to give me this angle of 11 pi over 6. And first of all, make sure you're giving me the angles in radians, because you're like, well, that's in quadrant 4. But remember, our restriction was negative pi over 2, 2 pi over 2. So you're dealing with the negative version of this angle, which is negative pi over 6. Inverse tangent of 1. So where is the tangent equal to 1? That's quadrant 1 and quadrant 4 I'm going to be looking in. Tangent's positive in quadrant 1, so that is going to be at pi over 4. Cosecant, root 3 over 2. Quadrant 1 and quadrant 2 are my restrictions. I am cosecant, cosine is negative root 3 over 2 at 5 pi over 6. Now right below this video you see the Google form. Please make sure you submit that on time.